Okay, welcome to the instructions for our Weathering of Rocks lab. You need to watch this presentation, and as you view it, you need to complete this sheet that was given to you in class. All I'm asking you to do is summarize what do you do in part A, B, C, and D. This doesn't have to be a formal paragraph, doesn't have to be complete sentences. What you need to do is prove to me that you know what you're doing, especially with some safety concerns that we have with this activity before you begin the lab. This must be done before you come into class. So this is a homework assignment. If you come into class the day of the lab and this is not complete, you're going to sit the lab out and you're going to have some kind of alternative assignment assigned to you in order to make up for this lab activity. So you're going to be given a piece of paper like this. You'll notice it has the names of 6 different rocks on there. There are buckets with the 6 different rock samples that we're going to test, and each bucket has the name of the rock on a card in the front of the bucket. You need to pay close attention about which rock you're picking up because some of these are going to look very similar to one another. So what you're going to have is the paper in front of you with a couple of pieces of each of the different rock types laid out in front of you. If you need more as the lab goes on, you can go and get more of these. But when you're done, I need you to make sure that you know which rock is which, because when we put these rocks back in the bucket, we need to make sure they go in the correct container. So now let's look at part A. What are we doing in the first part of this procedure? We're going to go get 6 of these empty Gatorade bottles because there's 6 different samples of rocks. You need to keep up with which rock is going in which Gatorade bottle. You're going to put about 3/4 of, fill the bottle 3/4 full with water. This is probably a little bit more water than what we want. And you're going to take one of the samples of rocks, or 2 small pieces if you want, and put them in the Gatorade bottle. Now let me caution you, you should not try to force the rocks through the opening. You might have a rock that seems like it's going to fit, but you got to really work at it. We don't want to do that because that means we won't be able to get the rock out when we're done. If your rock won't fit through the opening in the bottle, put it back or set it aside and go get a couple of rocks that will. You're then going to take the cap, put it on the bottle, and we are going to shake this vigorously for a minute. We're going to shake all 6 of these at the same time, and we're going to shake them at the same rate. So you're going to do something like this. There are 6 bottles, so this works best if you have a lab group of 3 and everybody's got 2 bottles, 1 in each hand, and you can shake them at the same rate. When you're done, we're going to line these out on the counter and we're going to observe how these different samples look different, and you'll fill in the chart on your lab sheet with your observation. So now we're done. We've made our observations and we've compared the 6 rock samples. We got to clean up. How do we do this? We're going to take this strainer, this colander, and we're going to put this over the drain out there in the launch pad area. And we're going to take our water bottle and we're going to dump it in there. Let the water drain into the drain and then take the rock sample out. Do this one at a time. Because if you dump all 6 rocks into the colander, I'm a little concerned that maybe we get a couple of them backwards and the rocks then don't wind up in their correct container. When you're done with that, put the Gatorade bottles back where you got them from. You can put your rocks back on your paper because we can use them again, and then we'll move on to part B. Okay, part B. We're going to go and take one of these rock samples, and we're going to pick it up, and we're going to try to test to see how hard is this rock sample? How easy is it to weather it or break it apart? And we're going to use 3 objects. We're going to test it with a nail file, emery board. We're going to use a regular common steel nail, and we're going to use a hardened steel file. First thing we'll do is we'll pick up this rock and we'll take the emery board and we're going to try to scratch it, especially with the side, and see, can we cut into the rock with an emery board? Some of these rocks are soft enough that this will make a cut or remove some of the rock. Now, it might be kind of hard to see. So you want to check these with a magnifying glass. You can take the magnifying glass and look and see, okay, is there a little mark now into the rock? blow the debris off, maybe rub it with your hand and see, am I really making a cut into this rock or not? Record your observations. You may do this as a group. One person can be doing all of the tests with the nail file, and then somebody else can take the nail and perform the same thing. Try to scratch the rock with the nail and see, does it make a cut? Will it break apart the rock? Same thing is true with the file. We're going to take the file and we're going to try to scratch the rock and see if we can make a mark. Record your observations whether or not you were able to weather the rock with an emery board, a nail, or a steel file. When you're done, you can just put your rocks back on your sheet because we're going to need them again. Okay, part C. Part C is going to be an acid test. We know that the acidity will change the rate of weathering, but not all rocks are the same. So we want to see which ones get weathered more easily with acid. And with that, we have a little bottle here of dilute hydrochloric acid. And you're going to take this and you're going to put a couple drops onto the rock. A couple of drops. We're not going to spray the rock entirely. We're just going to put a couple drops on there and look and see what happens. If the rock chemically reacts with an acid, you'll notice something different. You'll notice something happening. A chemical reaction will occur and you'll see something you didn't see before. Specifically, you'll see bubbles. This is a liquid. This is a solid. We don't have any bubbles here. If I put the acid on the rock and I start to see bubbles, I know that they are chemically reacting and this rock is being chemically weathered by the acid. So you're going to put a couple of drops on each rock and see if it bubbles or not. Record your observations. One safety note, we're not going to hold the rocks in our hand like this. Did this to show you in the video how we're going to do this. We want the rocks sitting on the table because we don't want to be dripping acid on something that we're holding in our hand and risk the acid getting on our hand. This is not particularly strong acid. It's not going to kill you. It's not going to burn your skin off, but we still want to be safe and drop it on the table, not onto our hands. And if we get some on our hands, we just want to make sure that we wash our hands and dry our hands completely before moving on. So now let's look at part D. What we're going to try to do in part D is physically break these rocks into smaller pieces and see which one's toughest, which one resists being broken the most, and which one is most resistant to weathering. For this, you're going to need to wear a pair of impact safety goggles. Even if you wear regular glasses like I do, you need to wear these over your glasses because your prescription glasses are not impact proof. We're going to take a hammer and we are going to try to break these rocks. Listen carefully to how we're going to do this because I will go ahead and tell you every single one of these rocks will break with this hammer if we hit them hard enough. That's not the point. We want to see how much force does it take to break the rock. So what you're going to do is take one of the rocks and set it on the ground, and you're just going to hit it softly with the hammer and see if it breaks. Well, no. Do that with all 6 of the rocks. Hit them about the same strength, same number of times, and see if one of them breaks or not. If none of them break, we're going to repeat the procedure, but now we're going to hit it a little bit harder. Do that with all 6 rocks. See which one breaks first. And then keep increasing the force of the hammer until we get an idea which ones are the strong ones and which ones are the weakest ones. Now, let me clarify for you. The point of this is not to make sure that we break every rock. Even the toughest rock, you can break with this hammer if you hit it hard enough. That's not the point. We want to get a relative scale about which ones are harder and which ones are softer. So you're not necessarily going to break every rock. And I don't want to see you just wailing on a rock, making sure that you can get it to break, because that is not the point. When you're done, we're going to rate these rocks as to which one is harder and which one is softer. We're going to come up with a scale of hardest to softest. So you're going to have to gently increase your strength of the hammer every time to get an idea which ones break first and which ones break last. So once again, this procedure has to be summarized before you come into class and start the lab. If you don't have that procedure summarized, if you don't have this document completed and it be correct, matching up what I expect you to do, you will not perform this lab activity and you'll be given an alternative assignment for this grade.